Hey, welcome back. Let's look at the long lost friend, the import Dbit grinder that I'm doing the general Renzetti modifications and a little bit more. This project is taking way longer than it should have, but there is usually customer parts coming in the way of working on it, and those have priority because, well, money. But it's up on the bench now. I want to get a little bit of progress on it. I purchased a new motor for it. The original motor is a single phase asynchronous motor with 0.25 kilowatts, 3000 RPM, and that was always on the weak side. For my money, it's too weak of a motor. The new motor in here is 0.37 kilowatts at 3000 RPM nominal, and is a three-phase motor, so the torque curve is also a little bit more beneficial. Also, it gives me the option to run it off a VFT to vary the speed of the grinding spindle. Motor is already installed. I changed nothing there. Grinding spindle is also back in the housing, and it still has its axial movement of 10 millimeters to allow for dressing. And well, let's look at the back plate here, which is the resting surface for the moment arm of the main axis here. This is the plate that the moment arm rides on and gives the depth, the grinding depth setting. That's one of the main Renzetti modifications. When I made the plate first, I wanted to send it out for hardening, but currently I don't have any parts to get a nice batch for the heat treater. So instead what I did, I took a piece of a high-speed steel blank, I milled a slot and I glued the high-speed steel blank in here with some acrylic structural glue, and I surface ground it. So I have a hardened wear surface here that's basically as hard as it gets. So that problem is solved. Next I need to finish this moment arm here. It needs a clamp here to go on the main axis, and it needs an adjuster screw back here to allow for this adjustment. Also, I made an aluminium ring with a pressed in lip seal. So this is where the shaft pokes through the casting with the Mowgli's bearing in there. And the lip seal will prevent any grinding dust from migrating into there. That's very important. Also, here is one of the grease fittings. Still not sure what I'm going to use for lubrication here. Maybe nothing, maybe a high pressure grease. Cool. So this is only band sawn on most surfaces. This, and this back surface need machining. And we need to drill and tap a fine threaded hole through there somewhere. And we need to make a clamp arrangement so this can clamp on the main shaft. I put the indexing head back on the milling machine, and I have the faceplate on, so I have a nice large surface to strap clamp the arm to. Sacrificial aluminum plate because I want to mill the perimeter of the part. Don't want to cut into my faceplate. And I have just an indicator here in the spindle to center the bore of this part on the indexer. Doesn't really have to be precise. This is just for doing some cosmetic work. So I'm fine with 20 microns that I have now. Let's tighten it down. So I want these cuts to be at 45 degrees. So I'm aligning this side here that is milled with the x-axis of the mill. And I'm just traversing, and at the same time I'm rotating the indexing head until I see that my needle doesn't move any more or less. At some point you have to realign because you out-travel the indicator, of course. Okay, that's good enough. Let's lock it down in this position. And we can zero out the dial here. And we can also zero out the large dial on the back of the indexer. That's a matter of loosening 4 screws, and then we can zero out this entire dial. Makes things a little bit easier if you have a known zero position. The last step is to find the center of the bore. It's not strictly necessary because we're only cutting parallel cuts and they're not real precise, but it's easier for repeatable work. Okay, so we're spinning too big, decreasing the fly radius of the indicator tip. I'm doing the rough center, then precision center method. So getting my indicator, putting the needle on 0 and zeroing out the DRO. Spinning approximately 180 degrees, zeroing out the needle again. Then I have a random value in the y-axis counter. I split that in half and I crank the y-axis to 0. Now we repeat the same procedure in x. We start here in x, approximately at 0, spinning about 180 degrees, finding 0 again. And we have about the same value as we had before in y, now in x, just minus. We split that in half and we crank x to 0. Now we should be very, very close to the center of the bore. Now we can bring the indicator down a little bit, make it contact the bore, zero it out, and now we can sweep the bore without having to fear to over travel the indicator. So 0 over here, approximately 1 here, 4, 0. So let's split the difference here. Yeah, that's within 10 microns. And that went really, really fast. But I always like to show how quick indicating can be to a reasonable precision without much fuss and without the coax indicator, because I really do not like coax indicators. So now that I sweep the bore, I can zero out the DRO in this position. So you get your 32mm wrench on there and you give it a sharp snap and it will break it loose. A 40 taper is not self-releasing, that's a myth. 40 taper is only self-releasing if the taper is sturdy or banged up like mad. A clean 40 taper is not self-releasing the least. It's less self-locking than a Morse taper, but it's far from self-releasing. So let's use this. Let's swing the part to 45 degrees so we can cut this angle here. Lock it. And now we can cut this angle with the X travel of the machine. Okay, first one cleaned up. Now I'm going another 90 degrees to the next 45 degree chamfer. We're cutting basically large chamfers here. And I have the suspicion that we will hit the strap clamp here. Oh, it will work out. Moving over to the vise, directly on the indexer. Don't want to put the table back on. I was recently asked in the comments how the 3-jar chuck on this indexer is registered, and the answer is it's not. Also, I was asked, I think it was the same commenter, the question was how I deal with run-out problems from the chuck since it's not a set-through chuck. Well, it's adjustable, just not in the traditional sense of an adjustable chuck. It can slide on the faceplate here. And I just semi-tighten the bolts, and then I use a soft-faced hammer to knock the chuck around until it runs true. That's a very economical solution to this problem. That allows me to use a very cheap 3-jar chuck on the indexer and still get a high precision. Move some set screws around. I need these. I plug the holes that I'm not using in the faceplate with set screws. Otherwise you're constantly bothered with cleaning out chips and oil from them. Just make sure they're below the surface when you drive them in. Also, there is a reason why I use slotted set screws for this application. They are easier to clean than internal hexes on set screws for this purpose. With a flat screwdriver, you can just poke the chips out compared to a hex head. So that's why I'm using the dreaded slotted head screws. Slotted head screws are not that bad. It's just people not fully understanding when and where to use them. And suddenly your press fit bushing becomes a sliding fit bushing. So That could have ended rather bad. But funny that it held up that well. So I will put the bushing back in and pin it in place so it doesn't slide around on me. You probably wonder why there is bushing in the first place. Well, maybe I overshot the bore in this part by like 50 micron and it was a super sloppy fit. So that's the reason why there is bushing in it. And I wasn't feeling like remaking the part. I'm hand tapping the M10 by 1 fine pitch thread because I'm not sure if the tap that I have is part of a multi-tap set. Usually fine threaded hand taps come in a set of 2, one for roughing and one for finishing, but I'm not sure about this one, so I was a little bit hesitant to run it on the machine power. Prefer to do it by hand in this case. But still using the milling machine as a tapping guide to be on the safe side. Also, this is a fairly deep thread. I think this is almost 30 millimeters. So I have a lot of thread engagement, and that will make the adjustment very slop-free. And also slow wearing. There we go. I think this is part of a two tap set, but it cut the thread quite well. So there's that part finished, only needs some deburring and chamfering. I have the casting that holds the entire workhead of the Dbit grinder on the main shaft here on the milling machine, because I need to modify the O-ring groove. I don't have a hook tool that's matching and I don't feel like grinding one, so I'm using a T-slot cutter. And this part has already a clamp slot in it, so I'm only putting a 25mm shaft in the collet of the indexer, and the part I'm working on is clamped using its own slot and screw onto the shaft so I can cut this feature. I found a T-slot cutter, and what I'm doing here is I'm replacing the O-ring in there against an X-ring or a quad ring. So let's get the indicator out there. I'm already centered on this part. And I get to use one of my very old school high-speed steel T-slot cutters. I recently found or used a carbide T-slot cutter, and I have to say, oh man, those are way nicer. Okay, let's pick up the C height. I'm dropping the T-slot cutter on the face of the part, like this. And I lock the quill and I zero out the C axis. As long as I don't open the quill lock, I have my C height now. And now it's just a matter of turning on the machine, feeding in an Y axis and rotating the indexing head at the same time. I've done that recently on customer parts and it worked very well. So let's go. Let's see if this ring wants to go in there. I'm using a wooden poker instead of a steel one to not completely murder this ring. There are proper ring installation tools, but I don't have them here. So that looks nice. Let's get it off the arbor, and you also see how the work holding is done. So it's really just clamped with a single screw on the shaft. And there is the quad ring inside there. I will replace it because this one already has some damage from me test fitting it. Let's do the other side. Part goes on the arbor again. We clamp it. And we take the same cut. So touching off with the quill, zeroing out the DRO. Ugh. Okay, second O-ring groove, or quad ring groove in this case. Okay, there we go. Second groove is cut. I will clean it before I put the rings in finally, so I don't mess up another of those quad rings. Also, I want to clean it or deeper the slot on the inside. Okay, and the finished moment arm, well, mostly finished. I will most likely add a second hole for an indicator to measure the infeed, to give me a measurable feedback of my infeed towards the grinding wheel. Robin had that on his design too, and I think that's a great addition. The fine adjuster screw that I have in here is not the permanent one. This is just the old infeed screw, the infeed stop screw from the Dbit grinder that just happens to have the right thread. And for testing purposes, I'm using that, or as a mock-up piece. So the moment arm goes on here. Just goes all the way out to the end of the shaft and gets locked with this one screw. The clamping here allows to adjust the relationship between the orientation of the workhead to the moment arm. Then it's locked in place. And now you have a very nice hard stop here for your in-feed into the grinding wheel. Imagine the grinding wheel sitting here, and we're in-feeding like this. The hardened strip back here is more than long enough to allow all the travel from the screw. And this plate can be leveled with the 3 set screws to be parallel to the main bar here. So all of that is looking pretty good. I'm very happy how this works. The added X rings in here, or quad rings, give a little bit more drag on the main axis when doing rough adjustment, but I feel like it's not a big problem. It feels good to me. Lockup is also very nice. So that's working out perfectly fine. I'm very happy so far. I also put the grinding spindle back in, motor is back in as I showed. Yeah, but now that the Deckel S1 tool and cutter grinder is gone, the desire to have the Dbit grinder back in operation is there. It has gotten a little bit more, well, not pressing, but it would be nice to have a Dbit grinder back. So, as you can see, the Deckel S1 tool and cutter grinder that was sitting here in this corner of the shop is gone. A good friend of mine purchased it from me. I noticed that I used it less and less, and I used the surface grinder with the digital readout for doing tool and cutter grinding way more, just because it's extremely convenient to set up on the magnetic chuck and just stack work holding to accomplish the same as with a dedicated tool and cutter grinder. That's the reason why my 6-month rule took over, and I had basically to sell it. So we salvaged the machine out of the shop. It's, for what this machine is, it's really heavy, and we chain hoisted it onto a pallet, or well, we dragged it onto a pallet with a chain come along, and then we put it on a pallet jack and went up the incline of my property here and put it onto a trailer, and it's gone. This nice little drawer cabinet here took place of the tool and cutter grinder, just a spot to work on small personal projects, while the rest of the shop is dedicated mostly to customer work. So currently here is the high-speed head for the FP1 sitting. It's almost back together. I need to order a new motor because the motor that was on it was not the correct speed. Somebody had mucked with it in the past, and it was a 1500 RPM motor, and it's supposed to be a 3000 RPM motor. So ordering a new one. Yeah, I could run the slow one with VFD at double the speed, but no. Circling back, Dbit grinder. Of course, I'm using the surface grinder now a lot for tool and cutter grinding, but the convenience of the Dbit grinder is that you often can just walk up to it, and especially with round tooling, like a lot of my lathe form tooling has a round shank because I use old end mill shanks. It's very convenient because it always has the collet head on it. It's very fast to set up. And I just don't want to abandon it. It's coming along nicely. It's taking way longer than it should, but we'll get there. We'll get there eventually. I can show you the Collet head. Here's the rebuilt Collet head. I didn't do much to it. The only real thing that I did was to grind the dovetails to be square and in line with the spindle. These were off by quite a bit. And also I ground them parallel. I do not have footage of grinding these. I used a dressed wheel to get in there. Apart from that, only a little bit of deburring, cleaned up this part here that holds the in-feed screw, added a shim to take out any backlash in this in-feed screw, deburred everything and put some green color on it. So that's the Collet head. It has ball bearings in it. I put new ball bearings in it, but it's only very inexpensive radial bearings that are preloaded against each other. Very simple setup, but very, very appropriate for the purpose. So that's that. Run out in the taper seat was always very good. For those who don't know, a quad ring looks like this. Looks like an O-ring, but with a kind of square cross section. If you cut the quad ring in half and you look at the cross section, it looks somewhat like this. It has two contact points with a small radius compared to an O-ring with its round cross section and having one contact point that if you squish it, it gets a very wide contact patch. And I figured for this purpose, two narrower contact patches would be nice. First of all, it keeps out dirt a little bit better. And also, friction should be a little bit on the lower side when moving it along. Also, I never used a quad ring, so that was a good excuse to learn about this part. Also, the original O-rings that were in the casting were an extremely sloppy fit on the main shaft and didn't do anything to seal against grinding grit. That's the main purpose of the O-ring on this casting, to protect it from getting all ground up with grinding dust. So I hope you enjoyed this slightly chaotic overview of what happened to the Dbit grinder. I know that a lot of people are waiting for these videos and updates on this project, but it's really going slow because I have to shave time away from customer projects, and those have priority because they that's how I can buy food. It's not that bad, really. I'm really doing very well here, so no complaints here, and don't worry about my situation at all. I'm not worried. Not even myself is. I'm not even worried myself. So I just have a ton of work coming in, and that's a good thing. That's a great problem to have. I started filming this exact video that you're watching right now in early 2023. That's the reason why it's a little bit chaotic and some footage has gotten lost over time, maybe. But I hope I still got the main point that what I want to achieve with this video across. I will be off to France for a week, doing a little bit of a road trip with a former colleague. But I will be back, of course, and during that time, answering comments will be very sporadic for sure, but I'm usually reading them all. I don't have a PC with me, I'm just taking a phone with me. So don't be mad at me, please. I read all comments, definitely. I don't answer all of them. That's mostly a time management problem, of course. But I try to, on new videos, I usually try to answer a lot of the comments. 50% is also a lot. So, thank you for watching, thanks for the support, and I'll be back.